In this video, I'm going to cover unequally disposed profile. So that's going to look at our symbol is a U with a circle around it. The symbol is called the unequally disposed symbol. You might hear some people call it the unilateral symbol. That's basically fine. People know what you mean. It only goes in one place, right? We have our feature control frame for profile. We're going to have our total profile value. And if we want it to be on one side or the other of the true profile or split unevenly on the true profile, we add in our unequally disposed symbol and then we give it a value. So the idea here is that we can do all of this in the feature control frame and just point to the surface like we normally would. Now, there's another way to do it that was used prior to the 2018 Y14.5 revision that I'll cover toward the end of the video. But let's look at this technique first. The way we would apply this, right? Say I'm going to look at this lower box down here. I'm going to give it a basic dimension. We'll give it a datum reference. And we'll call that datum A. And this is going to control the size, form, orientation, and location of this top surface, because the datum and the datum plane and the plane we're controlling are parallel with each other. So you don't need datums B or C or anything to give this any more meaning. They wouldn't do anything in this case. So the number here is going to be, and this is my paraphrasing, the amount of the tolerance zone that applies in the direction that would add material. Whether it's add material, in this case, like this, going up, or if we have an internal feature, adding material would be making the hole smaller, right? Now, there's other terms you can use. I really like the add material. I think it's very simple to get the hang of. So if you can remember that phrase, you'll be a-okay with this. So let's give it a value and try some things out. So the most common values you're going to see here are going to be a value that's equal to the total tolerance. So in this case, the way we read this, it's profile 40 thousandths unequally disposed. 40 thousandths of the 40 thousandths is in the direction that would add material. So this tolerance zone is entirely outside of the part. Our true profile is indicated right here, right? Just where our basic dimension tells us it is, and we're shifting that profile completely above it. So this distance right here is 40 thousandths. That's going to affect our upper and lower limit for this part. So now the upper limit, or MMC, is going to be the basic dimension plus the 40 thousandths, so 1.04. And the lower limit is going to be just that basic dimension, right? Because there's no tolerance allocated to, go into the part. That's a common way to see it. Now, why don't we, since I've got this set up like so, what if it applied to this hole? Right? And I know you don't see holes with basic dimensions all the time, but it is possible. We can do it. So in this case, I'll read this. I'll put an arrow on this leader. I'll read this out again. Profile 40 thousandths unequally disposed 40 thousandths in the direction that would add material. So toward the maximum material condition, which in this case is in here. So our tolerance zone only makes the hole smaller relative to that original true profile. So now to calculate our limits here, so say we wanted to know what the MMC and the LMC of this hole is, and I know the profile is applied, so it's not a feature of size. We can still think of it in terms of MMC and LMC. You could think of it in terms of upper limit and lower limit if you like. But what's going on here is before on this part, the profile only applied on one side, right? So we have the 1 inch plus 40 thousandths, we're done. With this hole, right, now normally the MMC would be the basic dimension minus the total profile. Here we've got to double our profile. If you see, we've got this dimension and this dimension totally inside. So our MMC is actually going to be a diameter of 0.92, and our LMC is going to be equal to that basic dimension. So it is a little bit different when you have a closed feature like that, or you're applying it all around. Just keep in mind, if the profile applies on both sides, you kind of got to double it. But it's one of those things, like, I hope you don't have to memorize this. It should be able to just sketch it out. As long as you know which way the profile applies, you'll be good. You can just draw a little sketch here and be like, okay, that's 40. That's 40. Done, right? Total of 80. Subtract it from the basic dimension. We're all set. So let's flip our tolerance. Now we're going to say 0. And it's just a habit of mine to match the number of decimal places. You really don't have to. I mean, 0 is 0, right? It doesn't have decimal places. So I know those out there that are using the metric system or SI units, so you just put 0. Either one is fine. Now, let's kind of read this out. We've got a profile, 40 thousandths, unequally disposed. 0 of that 40 thousandths is in the direction that would add material. So in our first example down here, we're going to shift our tolerance zone this way, right? Totally inside of the true profile. Here's our 40 thousandths, right? And we can calculate our MMC and LMC from there, or upper and lower limit from there. And I mentioned upper and lower limits. I got a question on somebody emailed me, so hopefully this answers a question for you. So our MMC is equal to the basic dimension here, and our LMC is equal to the basic dimension minus the entire value of the profile, because it only applies on one side. For an internal feature, let's just flip this around. Again, I'll give it a diameter of 1, make that basic. Okay, profile 40 thousandths, unequally disposed. 0 is in the direction that would add material. Ergo, the entire tolerance is inside of the part. Right? Our MMC is equal to the basic dimension, and our LMC is the basic dimension plus double the profile. Right? Again, we've got 40 thousandths here, 40 thousandths here. This LMC diameter is a diameter of 1.08. And, obviously on this part, the way I drew it, you'd have a condition where not good, right? Like a wall thickness problem. So you might want to keep it. It's not as obvious as what I'm trying to say when you do a unilateral profile that this is going to get doubled when you have a closed feature, whether it's internal or external. So just something to keep an eye on. Next up, what if we have an unequally disposed profile? So what if this number is 10 thousandths? So the way we read this, profile, 40 thousandths, unequally disposed, 10 thousandths is in the direction that would add material. So if I draw that, here's 10 thousandths on this side of the true profile. Oh, let me draw our leader here. We're looking at this one. And then we're going to have the remainder apply in the opposite direction, right? So we're just splitting it, just an unequal tolerance. This works fine, but it's easier sometimes just to move that basic dimension. This would mean the same thing if we just move this basic dimension down 10 thousandths, then we could just have a profile of 40 thousandths. Just depends what your design is doing. Sometimes people like round numbers, and I get it. In any case, your your tolerance zone boundaries don't change, right? So just like when you apply if we applied 1 inch plus 10 minus 30, which is equivalent somewhat to this profile as far as a plus minus dimension can be, your limits are still whatever this is, 1.01 and then 0.97, no matter how we decide to show that on the drawing. So if I wanted to change this, I could rewrite this dimension as 0.99 plus or minus 2, right? And my limits are still this, right? So just something to keep in mind there. Now, I said I would talk about the old way to do this. In 2009, the 2009 revision, you could still do this. You could do either or. In 2018, this is not allowed, even though if you put it on a drawing, people are going to know what you mean. So the way we do this is we have our leader normal to a surface. If it applies to a hole, we'll apply it. It doesn't matter as much if you apply it to a hole, but to a surface, it's normal to it, and you'll see why in a second. We have our feature control frame. Our feature control frame is going to look the same, right? There's no extra information in the feature control frame. And I'll put this over here so I don't get in the way. Okay. In order for a unilateral profile, we're going to put a phantom line either on the inside of the part or the outside of the part. And I didn't give myself a lot of room here, so just ignore that a little bit. So if I put a phantom line on the inside, right, this entire 40 thousandths applies into the part. It'd be equivalent to having a unilateral tolerance in this case, or unequally disposed tolerance in this case of 0, right? 0 of the total tolerance adds. I could put this phantom line on the outside, right, and point to it, and it means applies the other direction. The phantom line itself is just a set distance, right? It is not scaled, is what I mean. If for whatever reason you needed an unequal profile, what you do is put a basic dimension on the phantom line, right? You only need one basic dimension. So in this case, 10 thousandths of this 40 thousandths is inside of the part. The rest of the tolerance zone is on the outside of the part. The reason this doesn't exist anymore is it doesn't work as well with 3D models with model-based definition because this phantom line, it's a little more difficult to show. Whereas the other method, all of the information is in the feature control frame. In my opinion, if you're using, orthographic projection, if you're using 2009, go for it. You can use this all you want. Even with 2018, you can have a drawing, a general note that says, hey, we want to use the old system for profile. Please check Y145-2009 for information on how to interpret it. It can be more clear for people that are not as hip to GD&T, which sometimes feels like it's everybody, but it is more readable. It really is. It's just naturally more readable this way, especially for a beginner. So I hope you got something out of this. I made a video about this years ago, but I thought I'd update it with some new graphics. This is something that I know is confusing, right? This symbol and how it's used. If you take the senior exam for the 2009 standard, there's like 3 or 4 questions about this. So you want to really crush that. And it all just comes down to that phrase, right? The amount of the total tolerance applies in the direction that would add material. If you can remember that, or some version of that, you'll be all set. So if you enjoyed the video, please like and subscribe. Leave a comment down below. Let me know what you think.